we would like to know if this series converge or diverge. We have 1 plus 1 over 3 plus 1 over 5 plus 1 over 7 plus 1 over 9 and so on forever. And notice that everything on the top is just 1, and then on the denominator we just have the odd numbers. And let's figure out a formula for these numbers first. Take a look of the 3 on the bottom, for example. This is in the second term when n is equal to 2. We can look at this 3 as 2 times the 2 and then minus 1. Because 2 times 2 is 4, for minus 1 we have the 3. And we can do the same for this 5, for example. We can look at the 5 as 2 times this 3 because it's in the third term, and then minus 1. If you work this out real quick, 2 times 3 is 6, 6 minus 1, we have the 5. And in fact, that's how we can write a formula for the odd numbers. So I can put this into the summation format, sigma when n is equal to 1 to infinity, and then everything on the top is just 1. So the formula is just 1 over, the denominator is 2 times whichever the n value, and then minus 1. 2 times whichever the n value, and then minus 1. So I can just put down 2n minus 1. And that's the series, or in the summation format, in more compact form compared to the expanded form. And we're asking the same question: does this converge or diverge? And at the moment, we cannot really do any comparison test, but we can do integral test. So I'm going to take this and change this to an integral. This is going to be looked at as 1 to infinity, 1 over 2x minus 1 dx. And what we're doing is, we are trying to use the integral test. And the connection is that if this improper integral converge, this infinite series also converge. And if this improper integral diverge, this series also diverge. Okay? So let's just focus on how to integrate this. And to do integral, just believe in your integration skills and believe in your limit. That's all. So to integrate this, we will let u equals to 2x minus 1, and then we differentiate both sides. Du will be 2 dx. I want to solve for the dx, so dx will be divide both sides by 2. We have 1/2 du. So this is going to be the same as in the u world. And by the way, when x is equal to 1, u will be 2 times x, which is 2 times 1, which is 2, minus 1. So u will be going from 1. Okay, when x is 1, 2 times 1 is 2, minus 1, u is 1. And when x approaches to infinity, well, u will be 2 times infinity, which is infinity, and then minus 1, which doesn't really matter. So u will be still going to infinity. So technically, we have to change the limit in terms of u, but it just happen to be identical in this case. Anyways, we have 1 over 2x minus 1 is a u, and then dx, we know it's the 1/2 du. And then now let's just work in the u world. Let's put the 1/2 all the way in the front. So we have 1/2, and then this is in the u world, and u still go from 1 to infinity. So put on 1 to infinity, and this is 1 over u du. And the 1/2 just stay in the front. And to integrate 1 over u, we have ln, absolute value of u. And then this is going from 1 to infinity. And we can just do this 1/2. And then let me put the infinity right here, which is ln, absolute value of infinity. And then minus, I put a parentheses, so I'm not going to put down the 1/2. Put a 1 right here, ln, absolute value of 1. Well, what does this equal to? Ln of 1 is just 0, but ln of infinity is infinity. 1/2 times infinity, this is still infinity. And what we're saying is, because the improper integral ends up to be positive infinity, therefore this improper integral diverges. So we know this right here, it diverges. And the connection is, if this diverges, this also diverges. So I can say this infinite series diverges, and the reason is by integral test. Okay, so this right here will be it.